Engine Performance 1 Test 9. This shouldn't take too long. All of these could cause a high starter current draw, except what? Our choices are defective ignition switch, worn starter bushings, low battery voltage, or shorted or current starter windings. If you've got low battery voltage, it's going to take more amps to turn the starter. Did you know that? If you have lower voltage, which is less push, it's going to take more amps to turn the starter. It's going to require more amperage to turn the starter if you got low battery voltage. That seems sort of counterintuitive if you're thinking about Ohm's law. 1 volt pushes 1 amp through 1 ohms. But if you're trying to do a given amount of work, then more voltage is good, right? I mean, if you can go to where you've got so much voltage you're going to destroy something, but at the same time, when I used to convert these Volkswagen Bugs from 6 volts to 12 volts, the older ones, then what I would do is just leave the 6 volt starter on there. Well, to begin with, the 12 volt starter wouldn't fit the ones that had 6 volt, but you could leave that 6 volt starter on there and just spin the tar out of that 6 volt starter. I mean, but it only took half as many amps, because of that. Okay. So that's actually, a defective ignition switch is not going to cause any kind of high worn starter bushings would cause it because of the armature dragging on the field coil. Shorted or grounded starter windings would cause it to pull more amps, okay? Because you'd have some of that current going to ground. Technician A says current must be flowing in a circuit to test voltage drop. Is he correct? You have to have current flowing to check voltage drop. If you ain't got current flowing, it ain't happening. Okay, Technician B says voltage drop can be greater than the source voltage. He is not true.
You can't lose.
You're not going to drop more than you're putting in. That's all there is to it. Technician A says if a positive battery cable is hot, not enough current is flowing. Technician B says how many manufacturers recommend battery cable replacement rather than repairing, he didn't say how many, he just says many recommend battery cable replacement rather than repairing damaged cable ends. Nobody. Do you know some of those, none of those manufacturers require that or even recommend it, because you know how much some of these cables, like particularly on some of these diesel pickup trucks, you'll pay $100 for a battery cable on some of those things, because this thing is huge. It's like double aught cable and it goes all the way down and around down there. Furthermore, it'd probably be 2 hours labor to change the doggone thing. And it's kind of dumb not to go ahead and put ends on it, because you're not going to spend near that much doing that. So Technician A is the right one in that one, and that's the case right there. Technician A says, if starter drive clearance is too small, the starter will produce a noise during cranking. And Technician B says, if starter drive clearance is too large, the starter will produce a noise after cranking. Now, this right here, according to this, neither one of those guys is right. And basically, if the starter drive clearance is too small, what does that mean by that?
Isn't that why you put a shim in them sometimes?
It is.
And sometimes you need to shim it because it's making racket.
Is it going to make a noise because it's too close, though? Probably not, right? But, now see, these guys have got it backwards. Technician A says, yes, ma'am, come here. I'm sorry.
Just the only one I found with.
Miss Grimes, that's Gail Grimes. She's already paid that, and that's a blanket. Did they put that wrong PO on it?
No, that was the only one with single and with more than one. The rest of them is 5.14. That's the only one with 0.4.
Well, some of them, I think this one there's a Dodge pickup. I think that one took 6. Well, fiddlestick. Just lay that aside and I'll sort that out. Appreciate all your hard work. Sorry about that. But anyway, they got their backwards. Starter drive clearance is too small. It's going to make a noise after cranking. Why? Because the starter drive is going to try to stay engaged because it's bound up after cranking, right? There's your key, after or during. Okay, if the clearance is too large, in other words, if it's too far away, while you're cranking, it's going to act up. And, one time, this guy that was here, well, it was Alan's nephew, had this Chevy Cavalier, and his grandfather put a starter on it, and it had this super thick starter shim. on it. And his grandfather was thinking, well, it had a super thick starter shim on it. I need to put a super thick starter shim back. Well, that made the clearance large enough to where it was barely catching the tip of the teeth. Now, here's something that most people didn't know. If you switch a car off, like you can try this if you want to, mark the flywheel, right? Just make a mark on the flywheel, and you need to be able to get where you can see it. And switch the car off, and you'll be surprised how many times when you switch it off that flywheel stops at the same spot. When you switch it off, that mark will be real close to the same place every time you switch it off. So in that case, the starter is a lot of times hitting the same teeth every time it first kicks in.
That have a lot to do with, and this may be kind of out there, but resistances in the rotating assembly of the engine.
You're absolutely correct. There's going to be one place that's got slightly more resistance than everywhere else, and it's kind of like you're loading a roulette wheel or something, stuff like that. Not that I've ever loaded a roulette wheel, but you know what I'm talking about. Okay. Technician A says manufacturers sometimes use metal shims. By the way, did you hear how Sean was thinking? I was telling you, you got to learn how to think. He's thinking. He's a thinking guy, All right. Sean, where'd you learn how to think? He comes up with good answers like that sometimes just off the top of his head. You just learned how to think, didn't you? Yeah, all right. Must have learned that from your own point. All right, let me see. Technician A says manufacturers sometimes use metal shims to provide accurate starter drive clearance. That's on your Chevy where the bolts go in straight in from the bottom. Technician B says hitting a starter motor may damage the permanent magnets inside. Both those guys are right. Now, if you hit the starter motor really hard with a hammer or something, those magnets on the inside are ceramic magnets, and it'll crack them. If you bust a ceramic magnet, you shall ruin it. But if you just tap it gently on the end, if you're going to hit one, tap it back here where the brushes are on the very end, where you're not by those ceramic magnets, and don't hit it all that hard. Because why does the starter work when you hit it?
Because it frees it up sometimes. No,
the brushes are just about worn out, and they're not making good contact. And when you whack it, it jiggles that armature and it starts spinning, and then it'll go ahead and spin. Now, this morning on that Toyota, I stuck Derek with that starter job because we needed to come in here. But anyway, I was going to tap that starter. See what I did on that? You need to see this, by the way. That starter is one of those that's kind of got this big square solenoid built onto it on that Toyota. And the battery cable comes like this, like that, and it's hooked to right here. And then you got your little terminal that comes in through the ignition switch. And on this other side of this doggone thing, we've got a big heavy cable that's going right down into the starter motor. So whenever, and it's got 3 little screws here, but whenever you power this up, inside here there's a contact that's supposed to be made. It does 2 things. It throws that starter gear in, and it also, I'm looking straight at the back, it also makes a connection between this battery and that. And we were hearing this go clank when he went to crank it. Now, when he first brought it in, we worried with it for a while, trying to get it to start, and it would always start. But whenever he came back over here, I went to turn it, and this went clink. And he says, okay. I said, you get in here and you hold this key in the start position and don't let go of it. Because to start with, I tapped the starter and it didn't change anything. That doesn't mean the starter's not bad. Just because you tap it and it doesn't start the truck, that don't mean it ain't bad. But when he did that, I got here with my test light. Right here, I had good light. Ding, 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 ding. I had good light there. I got right here, and obviously we're getting it there. I got good light there. But with him holding the key and power here and power there, I had no power over here. It was just as dark as it could be.
That means it's open on the inside.
Inside there, and you can't change the solenoid on that one. Even on the ones you can change the solenoid on, sometimes if you buy a solenoid, it's $88, and a new starter is $110. So what's the point? You got all the other stuff wore out in there. And that starter, believe it or not, a rebuilt one, and I don't know how good it'll be, was only $42. That was pretty astonishing, wasn't it? $42 for a starter for that Toyota pickup. All right, so which component of an alternator is electrical current induced? The stator, yeah, that's that winding around the outside. The stator. The rotor spins inside the stator. The stator is the magnetic field sweeping across those windings in the stator. It produces alternating current. And then you've got these diodes. There will be 6 of them usually. And they'll actually grab that alternating current and turn it into direct current before letting it go out of the alternator. How many phases of AC electrical current are generated in the alternator stator? How many different windings are there in the alternator stator? There's 2 different ways those stators are wound that I know about. There's one where they're wound like this. If you just looked at the wiring of it, of course it's it wound to go around like that. And you got them 3 hook up like that. And then you got one that's joined in the middle. You still got 3. Got it? That's a Y wound, that's a delta wound. How many are there? 1, 2, 3. So how many phases are there? 3. There you go. That's not hard math, is it? Technician A says the battery must be in good condition and at least 75% charged to accurately test an alternator. He's right. And Technician B says alternator output should be tested at idle. You're not typically going to get anything at idle. All right. Now, let me ask you another question. I've got my battery right here, plus, minus. I got my alternator here, big post, and then my little wires plugging in. All right. Now, this wire here is coming off, and this wire right here is coming off, going, to places. If I put my inductive pickup around here, and I read 15 amps, and then I move my inductive pickup over here around this alternator wire, and I read 50 amps, what does that mean? Because that is the way it is. You'll read more amps here than you will there. Where's all these other amps going? I didn't mean to be confusing here, but
Resistance.
not resistance. There's no resistance there. You've got other loads. This is going other places besides the battery. Only 15 amps is making it to the battery. The other 35 are going other places on the car. Now, these numbers aren't hard and fast, but they're representative numbers, you see. So, what am I telling you this for? If you really want to know how much your alternator is putting out, you're going to clip around here. If you really want to know how much is making it back to the battery, you're going to clip around here. The arrow on your inductive pickup is going to be pointing away from the alternator and toward the battery. If you put it here, it's going to be pointing toward the battery. If you put it on the negative side, it's going to be pointing away from the battery. But I always like to check on this side.
That's pretty parallel with the flow or whatever.
Just because I like to compare that and that, but you can do it either way. Just make sure you're pointing your arrow the right way. The long and short of it is, if you're being comprehensive and doing a charging system test, if you're not so completely bored with this and about to go to sleep, then you're going to take your alternator and you're going to check it coming out of there too. You see, because I want to know that. When I was checking charging systems and I was want to be sure. Now, here's another thing. Let's say you got somebody that says, when I cruise around town, my battery goes dead. But when I'm driving down the road, it don't ever go dead. What does that mean?
It means that the alternator is failing and it's not deciding to draw enough or produce enough at low speeds, but when you're out on the highway or something, it produces enough.
If they got their air conditioner on, their blower, maybe their wipers, maybe their boom box bumping thumping thing that they're using, and all these maybe their headlights on. All right, the way you find out about that, you put your inductive pickup on here, and you turn everything on in that car that you can think of that's going to burn some juice that they may be running. And you know what you'll see in a case like that? You'll see something like -4 or something like that. Now, when you rev it up, this goes up. But just idling, it's not putting out enough.
It means it's taking 4 amps from the battery every time.
Taking 4 amps all the time when you got all those accessories on, because all of this is going somewhere else, and it ain't making it back to the battery. This right here ought to be at low speed. Your loads on the car's electrical system should be less than what this putting out, so you're always got a little bit of a plus there. See, you want this to be always a little bit of a plus. You know, even if it ain't much of a plus, it'll hold its own. But imagine what happens here if you're driving around, puttering around town, and you wind up with this minus business going on. Even if it's just -1 or 2, it's like the alternator ain't putting out, and you're using battery power slowly until it's all gone. All right, now we got one more here. Technician A says, let's see, if an alternator voltage output rises then falls as engine speed is held at 2,000 RPM, the belt might be slipping. Technician B says, it uses a scan tool to observe charging system voltage. Who's right about that?
How often does a belt slip?
Well, not as often as it used to, but it still can. If it's got grease or something on it, it can slip. And you know, think about what they do. This is something else that I always forget about if I don't mention it. This is an engineering thing. How big is the crankshaft pulley usually?
About 6-inch diameter.
Roughly 6 to 9. Okay, how big is the power steering pump?
About 3.5 to 4.
Usually, it's fairly big. What about the air conditioner pulley?
Be about the same.
Yeah. What about the alternator pulley?
2.5.
All right, why?
I want to spin faster.
Hmm?
You want to spin faster.
That's part of it. But these other ones here, it's double reason, yeah. This is going to pull some load, but you want it to spin fast, particularly when it's, and so, believe it or not, on some cars, I used to get a smaller pulley and put on the alternator when I was trying to engineer it so it would, you know, spin it a little faster. But anyway, these are bigger. Why would these be bigger? Is it because you want them to spin slower?
Because if you have them going too fast, it might damage the hydraulic systems in like the power steering pump or.
Well, not really. I'll tell you what's going on here. That power steering pump putting up 1,200 pounds of pressure, 12 to 15, and it needs power. So if you've got a big pulley, you got a lot of belt traction on it, you got more power. The air conditioning, how much is it putting up? 350 pounds of pressure it's building, and it needs to have, it needs to have a big pulley on it too. So you got a big pulley on stuff that needs a lot of power pulling it. You got the little one on the thing that's spinning faster.
They always take the ruffled side of the belt too.
What was that?
On all of those pulleys, they always take the non-smooth side.
Now, what about your, typically, what about your water pump?
Generally, it's smooth.
But what about the size of the pulley?
It's generally about 3 inches.
It depends on what's driving it. If the timing belt is driving the water pump, the pulley will be small. That's typical. If the belt is driving it, it's going to be as big as one of these. Now, why is that? You spin the water pump too fast, it cavitates. It starts whipping up bubbles in there. See where I'm going with that? Okay. Now, did you guys just learn something from that little exposition that you didn't know before? Stuff you didn't think about that engineers have to deal with every day, right? And I'm not talking about the guy that drives a train, okay? What alternator components are responsible for converting AC to DC output? Diodes. How many electrons are there in the valence ring of the material that makes up a diode?
What makes up a diode?
Silicon.
Silicon.
Usually you can have other kind of diodes, but let's just say it's silicon.
It's a semiconductor.
That's right. He's going there.
Has 4.
4. If it's got 4 electrons in there. Okay, now here's another little piece of trivia. And I told you this before, but I don't want it to sink in. You bring the nucleus of an atom up to about that big, it's like 2 to 3 miles to the first electron ring. Did you know that?
Yeah, that's 97% of the world's energy too.
Yep, there you go.
It's the energy that holds protons and neutrons together in the center.
He reads a lot. 0 point energy, that's what you're talking about, isn't it? All right, now, if you took the amount of solid matter in an atom and you compared it to the amount of empty space in that same atom, the ratio would be like 1 second. Is that a second or a minute? Let's just put second. To 30 million years. That's the difference in the ratio between the amount of solid material in an atom compared to the amount of empty space. This would be empty space and that would be solid.
Why did they put that in time, though?
Just put it in time because it's the way you can focus on it. You put it in anything else. You can put it in something else too. The ratio can be expressed in anything. Time just works. Okay, but think about that. Most of what we got out here is empty space. And whenever the particle physicists found out that electrons only behave as particles when you're watching them. If that doesn't bother you, you didn't listen to what I just said. They only behave as particles when
Who
you're...
was it that said something about the observation? Crap. I don't remember his name.
Einstein said, I think it was Einstein that said, this reality that we live in is nothing more than a stubbornly persistent illusion. That's what he said. But see, it's mostly empty space. This is what the atoms, you know. And you know, hey, here's something else. Did you know that 95% of a tree comes out of thin air? The wood and all that you see in a tree, 95% of it comes out of thin air. Only 5% of it comes out of the ground. It actually comes from, photosynthesis and all that. And also, nobody knows how the water gets from in the ground up into the leaves. I mean, I haven't been able to figure that out yet. It seems like it'd be simple, but, you can't really track it. Okay. Anything?
If you take and put paint and water in the soil of a plant, it'll change the flower color.